Lesson 29, Quadratic Equations, Example 5. Given that ax squared plus bx plus c equals 0, we have to prove that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this is a very important formula. Okay, let's start off with the formula here. Now what I'll do, I'll divide throughout by a. Divide all this through by a. And we get this result, x squared plus b on a x plus c on a equals 0. Now what I'll do now is I'm going to complete the square. So what I'll do, I'll take the c on a across the other side, making it minus c on a. Now remember what we did before? We take this, we divide it by 2, so it becomes b over 2a, and then we square it. So that's going to give me b squared on 4a squared. Okay, and we add b squared over 4a squared to both sides. Alright, now this is now a perfect square, so this will be x plus b on 2a all squared. And you can check that out and expand it out if you like, just to see if this does work. Now this is over a common denominator of 4a squared, so I need to multiply that by 4a. So that's minus 4ac over 4a squared plus b squared over 4a squared. So now it becomes b squared minus 4ac all over 4a squared. Now remember the formula? So we've almost got it, haven't we? Almost there. Now, all square there, sorry. Now we take the square root to both sides, so x plus b over 2a equals, don't forget, plus or minus square root of b squared minus 4ac all over 4a squared. Now remember your rules of surds. That's plus or minus the square root of b squared minus 4ac all over. Now the square root of this one is just 2a. So that's equal to, taking across the other side, minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a, and seeing they're both over the same common denominator, x, therefore, finally x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and that is the very important quadratic formula. Now we're going to solve x squared plus 2x minus 1 equals 0. Now remember what I said before. If this is monic and that's even, then I would not use the quadratic formula. I'd use the completion of the square method. I am going to use the quadratic formula to show you it's a little bit long and cumbersome compared to the other technique. So here we go. We know that our a, coefficient in front of the x squared is 1. Our b equals 2, and our c equals minus 1, and our formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So substituting those values in, we get x equals minus 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times negative 1 all over 2 times 1, which is 2. That's minus 2 plus or minus square root of, now this is 4 minus, and a minus gives you a plus, so it's 4 plus 4, which is 8 over 2. Now that is not fully simplified. We have to now simplify this third. That is 2 root 2 over 2. And of course this is a common factor of 2 will come out. Get minus 1 plus or minus root 2 on 2. These cancel, and there are our solutions. And you must give the simplified solution. Now compare that method now. I'll run along the side and look at the completion of the square method. Watch how quick it is. X squared plus 2x equals, take 1 across, halve that number, 1, square it, 1, add 1 to both sides. This now is a perfect square. X plus 1 all squared equals 2. X plus 1 equals plus or minus root 2. So x equals minus 1 plus or minus root 2 are the solutions. Much faster, isn't it? The formula takes over when you've got a number here which is like a 3 or a 4 or something, and this number is an odd number. Then the quadratic formula has the advantage. Okay, now we're going to use the quadratic formula for this one. So we're going to write down A equals 2, B equals 3, and C equals negative 1. X equals minus B plus or minus square root of B squared minus 4AC all over 2A. We're just going to pop them all in. And it's going to be minus 3 plus or minus square root of B squared, which is 9, minus 4 times 2 times negative 1, all over 2 times 2, which is 4. That's minus 3 plus or minus square root of, now minus and minus give a plus, that's 8, so that's 17 on 4. Nothing to simplify here, so there are our solutions. And you may leave it in that form, it's acceptable.